Hello everyone. In today's video, we're going to be talking about TSQL transactions. A transaction is a set of commands that are meant to be executed together as one event. Sometimes they're referred to as a unit of work. The idea here is if we're taking a set of steps that are meant to be executed together, that we want to combine them together into one logical action so that either all of the steps happen together as a group, or that all of the steps do not happen. So what that means is if we encounter an error or some other kind of roadblock during the execution of the steps, that the previous steps would be reversed or what we call rolled back. So in order for us to write a set of steps, typically they're comprised of at least two action queries. So we would want to be combining two or more action queries together where either all of the work is committed and all of the changes are applied to the database, or if it doesn't work, that everything that has been changed gets rolled back. When we're forming a unit of work, we use these two keywords, begin and commit. And anything between the begin and commit is conditional based on whether the actions have succeeded or failed. And if any of the actions in the transaction fail, the transaction is rolled back. So let's take a look at some of the useful functions or variables that we can use during a transaction. The first one is the system variable row count. Now you can see in this example, the row count system variable is starting with two @ symbols. In TSQL, a variable is denoted with an @ symbol if it is a user-defined variable, but two @ symbols means that it's a system variable. In a later video, we're going to learn more about variables. For now, let's take a look at the row count system variable. This variable tells us the number of rows that were affected by the previous query. So in the course of executing some kind of action query like an insert, update, or delete, after that query has taken place, SQL Server informs you how many rows were affected by that query. Typically, we need to know whether or not our action has affected some change in the table. So in this example, we can see that there is a delete action query here. It says delete from employee where emp no is greater than 50. Now, in this particular example, you can see there's an if else. We're going to learn more about those in an upcoming video as well. But for now, we're going to focus on the condition of the if statement where it says if row count is less than 1. So row count is telling us how many rows were affected. Any value less than 1 tells us that 0 rows were affected by this query, which means that you tried to delete something, but nothing was actually deleted. So in that case, we would show a failed message, telling us that the delete query did not actually delete any records. Row count is very helpful for transactions because that's one way of verifying whether or not your action had the desired consequence. Let's look at the next example. Now on this slide, we're taking a look at another function called scope identity. Scope identity is a function that's built into TSQL that returns the last generated ID value. So if you've performed an action that generates an identity value, like for example an insert, then scope identity will tell you what the last value is. Now let's take a look at this example. The first action query here inserts a new record into band with a band name and band genre. The band table also has an identity column for band ID. But when we perform our insert, we have no idea what ID is going to be generated for David Bowie. If our ultimate goal is to insert a new song into our song table, but we don't know what the identity of that band is going to be, then when we want to perform those two actions, and we have to make sure that both actions happen together because we can't insert the song without inserting the associated band, because band and song are related. You can't have a song without referring to the band ID. And if we don't know the band ID, this is where scope identity comes in. So in our second insert, you can see that we have to insert into song the title, the release date, and the band ID. So where are we getting the band ID from? We're using scope identity. Calling that function tells us the last generated identity value. When we're performing these two inserts, these two action queries, we want to put them together in a transaction so that we can make sure that if the insert into band fails, that we don't continue on and try to insert a song with a band that doesn't exist. Scope identity will fail as well. So we're going to put them together in a transaction to make sure that either both of them happen or none of them happen. That way, if band insert fails, we're not going to try to insert the song. And if the song insert fails, we're going to roll back the band because we don't need any bands in our database table that don't have associated songs. So let's put this example into SQL Server. I'm going to start by making sure that we switch to our music database. And we'll take a look at what we have in band and song. I'll move this up a little so we can see it all. So we can see down here that we have some song data, including the band ID. So we'll be able to use that foreign key value to figure out which band is associated with which song. And when we want to perform those insert statements, we want to put them together in the same transaction. So I'm just going to copy them from the slide into here. In order to group them together in a transaction, we're going to begin the transaction before the first insert statement, and we're going to commit or complete the transaction after the second one. In order to visually identify the code that is going to be inside the transaction, we just make sure that we indent one level. So we start with the keyword begin. And I'm going to begin a transaction, and typically we give our transaction a name. The reason why we would give our transaction a name is so that we can refer to it later in code. If we get to a point where we have nested transactions and we want to kind of break out and maybe just complete part of it or just complete one of them in a nested statement, then we can refer to it by name to tell it which one we want to complete or roll back. So we're going to begin a transaction called, insert new song. You can name it whatever you like as long as it gives you some idea as to what is happening here. At the end, we're going to commit the transaction, and we have to make sure to repeat the same name. So the easiest way to make sure that you have the exact same name is just to copy and paste it. That way you don't have to worry about typos and things like that. So now we have this transaction, but we haven't specified what to do or how to handle it if one of these two things in here fails. Now there are a few different ways that we can handle the transaction not completing. But the easiest way to do that, in my opinion, is to use something called transact abort. So we can use a statement that says set transact abort to on. And when we set that to on before beginning a transaction, it will cause the transaction to abort and roll everything back automatically if any errors occur. So let's put our set transact abort to on. And this, like many database settings, is just like a light switch. So it's going to stay on until I turn it off again. So by setting this on, it's saying automatically roll back this transaction if something causes an error or fails. So let's do something that's going to cause an error. How about, let's put in maybe null for a song title. I do believe that song titles are marked not null in this table, but I'm just going to double check it just to make sure. So this column, song title, is marked not null. If I try to pass a null, it should cause an error. And when this error happens in this statement, because it's in a transaction that is going to be automatically aborted if anything goes wrong, we'll see that even though this is completely fine and will execute without error, when the error happens here in the same transaction, it will roll it all back. So not only will we not get a new song, we will also not get this new band. So we execute the entire thing. We can see that we got an error message here. Now let's take a look at our band table. And we can see that we did not get David Bowie added to our band table. So just to reiterate that, you'll notice the one row affected message from the first insert. So this insert initially was successful, but because of the errors here, and because they were together as a unit of work, they're saying this failed, roll it all back. So despite the fact that it looks like it worked, it was reversed when we encounter an error in the transaction. So that's one way to implicitly roll back, is by using this transact abort setting. Let's look at another example. This example is a little bit larger. So inside the transaction, we're making an insert statement into university enrollment table. This example is using our Ironwood database, and it's trying to enroll a student in a section. In order to enroll a student in a section, two things have to happen. The first is we create an enrollment record that says this student is enrolled in this section, and we also assign them a grade. Of course, when you first enroll, your grade is null. But we're enrolling student number 6 in section 10. When we do that, we also have to update section 10's record in the section table to keep track of that section's enrollment number. Which means is we're trying to keep track of how many students have enrolled in this particular section. Now, typically we would perform some kind of calculation just to calculate it, but for the purposes of this example, we're using the section's current enrollment field and adding 1. So when we try to enroll a student in that section, then we're going to update that enrollment and increase it by 1. Now, what we're going to do in the future, in a future class, once we learn a little bit more about transactions and when we learn a little bit more about variables and values in TSQL, our next step would be to make sure that the current enrollment isn't exceeding the maximum enrollment for that class. So let's say, for example, you have 30 seats in your classroom. What happens if 31 students enroll? Well, we'd want to reject them, not allow them to enroll, say that the section's full, and we'd have to roll back our enrollment record. For now, though, we're just going to stick with these two examples of inserting an enrollment record and increasing the number of students enrolled in that section. And then here's something new. We have a print statement. Now, print statement is just creating the user output to the console. When we get to this point in the print statement says transaction succeeded. Because they're happening step by step, we will only get to the transaction succeeded part if the insert succeeds and the update succeeds. Because if either one of these fail, we will immediately stop and roll back the transaction. So we would only ever get to the print with a nice success message if we made it through the rest of the transaction. So let's put the print message into our transaction. So let's try it again. I still have this error message, so we're not going to see this success message here. Let's execute that. You see we do not see the band and song successfully added. Now, if I actually do this correctly and provide a song title, now the insert should work as it did before. This insert should work. We're looking at using scope identity to find out the band ID of David Bowie. We don't know what it's going to be yet. We can bring this up. I can take a guess that it will probably be 11 because our current band table is at 10, but we don't know. You know, there might have been another band in there that got deleted or something like that. So we don't know what the identity is going to be until it's generated. And whatever it is going to be returned by this, passed into this insert statement. If we get through both of them successfully, then we'll get to the print statement. If we don't, though, we're just going to see that error message and the rollback. So let's give this a shot now. We will execute this. Now I've still got an error message. So we didn't see band and song successfully added. You'll see we see something else. We have another not null field that we didn't fill out. So I'm going to take a closer look at my band table and we'll see what we have to specify. So we need a song title, a song writer, and the song ID, and the band ID. So it's songwriter that we're missing. And I'll just add in that value. So we'll add Bowie as the writer as well. And let's try our transaction again. So now we've got one row successfully inserted into band, one row successfully inserted into song, and here's our print message. So we're able to get a success message by putting it at the end of the transaction before it's committed. But if the transaction fails, we can't inform the user other than the default error. So let's take a look at another example that allows us to inform the user with a nice error message if something goes wrong as well. In this approach, we put our transaction into a try-catch block. So in TSQL, we have try-catch, similar to how we would perform try-catch in C#. The syntax is a little different, but the concept is the same. We're going to put our transaction into a try block so that we can make an attempt. If any errors occur, then the try block stops executing and we get redirected into the catch block. But the one thing that you have to make sure that you do in the catch block is include this rollback statement. So in this case, we want to make sure that that transaction explicitly gets rolled back. So this can be used as an alternative to using that transact abort. If we go back, you can see I was using transact abort here that automatically rolls it back. When you're using try catch, you explicitly roll it back because you're transferring control here. This is part of the reason why we give our transaction a unique name. So if we want to inform the user of errors, we can do so in the catch block. We also have to make sure that we roll back that transaction so that anything that was started in the try can be removed in the catch. So here's that same example, but using try catch instead of transact abort. In this try block, we have the entire transaction, begin and commit, with the two action queries that we're grouping together. You'll notice now that the print statement with the success message happens after the commit. That's because we only want to get to it if the entire transaction is completed. We also want to make sure that we don't get to it if any errors happen. So if the insert fails or the update fails, we would immediately leave the try and go down to the catch. The catch rolls back the transaction and also prints a failure message. So now we get an output message either way. And this is the beauty of the try catch, is it is a little bit more work, but it allows you more control over exactly what happens. And the catch block isn't just used for, printing a message. You can use it for maybe if you have a table that logs errors, this is where you would insert a record into your error log. When you tried to make this happen and you got rejected, you could create an error about that and log it in some table. Or, you might want to have this point. This is where you create your backup because something isn't working right in your database. So there's a lot of things that you can do in a catch block. Let's put our example into a try and catch. So again, when we're going inside a statement, we want to indent to the next level. We start with begin try, and we finish it with end try. So you might have noticed something about TSQL, is that there are no brackets that are enclosing our code blocks. This is different from some of the other languages that you are familiar with, that we don't enclose code blocks with brackets in TSQL or parentheses. So how do we know where and when a block begins and ends? Well, we use the word begin at the start, and typically it's end at the end. But sometimes, we use a different keyword. It depends on what kind of structure we're enclosing. So we're going to look at a bunch of different kinds of structures over the coming week, and we'll learn how to format the code correctly. But in this case, if we were doing this in C#, we would have something like this with a try block, and then we'd have a closing bracket here. That is not correct formatting, though, for TSQL. So we start with begin try, and we complete the try block with end try. And same goes for the catch block. We have begin catch at the start of it and end catch to complete it. So inside the catch block, we want to make sure that we roll back that same transaction. And also now we can get a nice error message. Whatever we want the error message to say. Now, last but not least, I'm just going to move my commit statement so that the print statement happens after the transaction instead of inside it. Now, it doesn't matter too much if your print statement is inside or outside, but I think it makes more sense to have the two print statements at the same level. So here's our explicit error handling with try and catch. And as I mentioned before, inside the catch block, you could have any code that happens on error here. Now I don't want to perform a double insert, so I'm not going to execute it again, but you'll see that if you try to execute this, instead of the previous one, you would have the same outcome. The only difference would be that if you try to insert something that doesn't work, then you would see an error message in the messages pane instead of just the thing not working and throwing that typical SQL red error message down here. So how do we know which one to use? Well, there's a lot of similarities between the two approaches. Both of them allow you to roll back the transaction if any part of it fails. With transact abort, the rollback happens automatically, and we know how it goes with things that happen automatically. Sometimes it's less code, sometimes it's more convenient. However, it gives us less control. If you're using try catch, it's a little bit extra code you have to write. You have to remember to explicitly roll back that transaction. You have to tell it to roll back. But with try catch, you get the benefit of having that catch block. It gives you the opportunity to take other actions when the transaction fails. So the example that we did is printing a failure output message, for example. So I think creating a transaction is a pretty straightforward concept. If you have actions that need to happen together as a unit and you want to do them all or nothing, then you enclose it with a transaction. Now, in the previous video, we did an example that referenced a transaction. So let's bring up that example and we'll go over how we would add a transaction to an existing set of commands. So I've opened up the notes from the last video. The topic was concurrency and auditing. And we had this set of actions here where we wanted to change what the default constraint was on the updated on field. Because we started out pre-populating it as January 1st, 1900, so we wanted all of the old records to be pre-populated with that value. But any new records going forward, we want those to be pre-populated with the current date and time. So we wanted to change the default constraint on that value. And in order to do that, we had to drop the existing constraint and then recreate it. But I mentioned that in the future, we want to make sure both of those actions happen together. Because what would happen if you try to drop the constraint and that works, but then the new constraint doesn't work? Well, then we've left that field without any default value. Or what about the opposite being true? What if we try to drop the constraint and it fails, and now we're trying to add a second default constraint when this one is still existing and wasn't dropped? So that's going to cause an error as well. So we want to make sure that either both of these things happen, the old one gets dropped and the new one gets created, or that neither of them happen and the table is left alone as is without changes. So all we need to do in order to make sure both of these things happen together is we can choose an approach, either transact abort or try catch. I'm going to choose try catch here. So we'll do begin try and end try down here, begin catch and end catch. So there's our outer code blocks. Let's indent everything that's inside of here. Now we need to put this in a transaction. Sometimes students forget to put the actual transaction part because you think putting it in the try is good enough, but that's not the case. In order to be able to reverse changes, you need to put them in a transaction. So again, I'm going to indent this one more level, and we're going to begin the transaction. And I'm just going to call it change default updated on. So we begin the transaction here. We're going to commit the transaction at the end. And if it works, we can print a nice message that says defaults updated. In the catch block, this is where we roll back the transaction. And print an error message. So we could inform whoever's executing this script, hey, look out. You tried to do something, it failed. So now this set of commands will attempt to change the constraints, but if anything goes wrong, the attempts will be rolled back, the table will be left as is, and we would get a message notifying us that what we tried to do did not work. Or if it did work, we'll get this success message, and then we'll just continue on. Okay, so that is it for transactions. A nice, easy, simple way to make sure that changes that need to happen together are either executing all as a unit or being rolled back as a unit. It's an all or nothing sort of thing. And it can be very handy when you are taking multiple actions against a table or multiple tables. And if they all need to happen together, you can enforce that using transactions. So if you have any questions about this or any other course topics, please send me an email, and I will see you next time.